charts. So we're starting the quadratics unit, and so we're going to look at an application question to figure out some properties of quadratic functions. And we're going to look at more applications as we go through this unit. But kind of starting with an application, look at properties, how to graph quadratics, all that kind of stuff, and then get back to more applications. So, Peach's perfect pen, what does that mean? Well, Tiffany is actually Mrs. Tong's daughter. Mrs. Tong used to teach here. When she was a little girl, Tiffany had a strip of sheet metal that was 200 centimeters long that she wanted to bend to make a rectangular pen for her hamster named Peaches. The pen is to have a perimeter of exactly 200 centimeters, and being a humane pet owner, she wishes to make the largest pen possible so that Peaches has plenty of room to scamper about. So not knowing which dimensions would give the pen the maximum area, Tiffany decided to test several scenarios by varying the width of the pen. She used the perimeter formula. Perimeter of a rectangle is 2 times the length plus 2 times the width, and begins with a width of 10 centimeters. Obviously there can be widths in between, but we're just looking for a pattern going up by tens. So if the width is 10 centimeters, what's the length of the pen? So think about it. 200 is the perimeter, and so 2L plus 2 times 10. All right, so when you subtract 20, 180 divided by 2 is 90, and this is in centimeters. Really, what you're looking for, if 200 is the perimeter, then 100 is equal to the length plus the width, right? Because in a rectangle, you have 2 lengths and 2 widths to equal the perimeter. So 1 length and 1 width is half the perimeter. What's the area then? Well, 10 times 90 is 900 centimeters squared. Okay, so she's going to test several values. She sets up a table, choose a reasonable set of values for the width, and complete the table below. So maybe pause the video and fill it in. I'll come back in a sec. Okay, so charts filled in, areas calculated. Notice how basically once you get to 50 for the width, then you're really repeating the values, because the width now is 60 and the length is 40, which is the same as the width of 40 and the length of 60. In any case, we're going to graph these. We have to label the axes. So we want to put in our horizontal axis width, and that's in centimeters. Vertical is going to be the area, not the length. That would be just a linear function if you're graphing length versus area. Area then is centimeters squared. Okay, so again, pause the video and plot these points. Okay, so points have been plotted, joined up with a curve, axes labeled. So we've kind of worked ahead a little bit here. So the independent variable is the variable for which you choose the values. The dependent variables are the values that you depend on, that depend on what you have chosen for the independent. So here the independent value is the width, and the dependent is either the length or the area, okay? But as I said, we don't really care a whole lot about graphing length versus width. We care about what's happening to the area, because she wants to get the maximum area for her hamster. So on the grid above, use the values for the width and area to draw a graph. So we've done that. Label the axes. We've done that. Okay, the name of this curve. So if you haven't heard of it before, I think we've talked about it back in 10 IB. It's a parabola. That's a special name for a quadratic function. So parabola. The domain of a relation is the set of all possible values of the independent variable. So what's the domain of this relation? So any parabola, the domain is actually all real numbers, but in this case, it doesn't make sense to have a negative width or a width more than 100. So in this case, W for our width, all values of W, where W is greater than or equal to 0, less than or equal to 100, and an element of the set of real numbers. Range, we'll take a look at your graph here. Maximum was at 2500. Again, can't have negatives. So for a parabola, it would be everything less than or equal to that maximum value. In this particular application, this is A for area. That's going to be, the area is between 0 and 2500. And it's a real number. Okay? And that maximum is the 2500, and that was centimeters squared. What width and length give the maximum area? So a width of 50 centimeters and a length of 50 centimeters. Okay. Which part of the graph do you use to determine the maximum area? We use the vertex. Okay. So the vertex is that maximum point, okay? The vertex of a parabolic curve is the exact point where the curve changes direction. So it changes from going up to going down. What are the coordinates of the vertex? So that was 50, 2500. So this is your width, and this here is your area. Okay, so it says, how does the vertex relate to the maximum area and the width that gives it? So the first value is the width, and the second value is the area. What is the minimum area of the pen, and what width and length give the minimum area? Well, that would be 0. There wouldn't be. So 0 centimeters squared, and that's when width equals 0 or 100. So basically, there would be no length. Okay. Note that the curve is symmetrical with respect to a vertical line. We call that the axis of symmetry. We're going to use that a lot in this unit. Draw the axis of symmetry on the graph. What's the equation of it? So go back to your graph. Axis of symmetry, I'm going to do it in red. So it goes through the vertex. Okay, so that's the axis of symmetry. What's the equation of that? Remember, any vertical line is x equals, but in this case our x is w. So this would be, oh dear, this would be w. Give me a sec. This would be w equals 50. Okay. So what is the equation? It's w equals 50. All right. Use the graph in question 3 to estimate the area when the width is 25. So go back to your graph. When the width is 25, so basically, actually I'm going to use green. Width is 25, so you want to go up to your graph and then across. Okay, so looks to be a little bit more than 1800, so maybe 1850. And these are just estimates, right? So I'm not being terribly accurate. And then 45. So that is slightly above 2400, so maybe 2450. Okay. Use the graph in question 3 to estimate the width when the area is 2100. So 2100, maybe I'll use red here. So that's going to be here. Now 2100, that was a particular value, 30. And then if we go across, 30, and 70. Because really, length, if width is 30, length is 70, and vice versa. And then 2275, 2275 is just a little bit above here. So that looks like 35, maybe 37. And 63. Okay, so you can use technology to help you graph. However, for a calculator to be able to graph relation, it needs to see the equation uses x and y. So it's going to be in the form y equals. So if the perimeter of the pen is 200 and x represents the width and L represents the length, write an equation for length in terms of x. Okay, so perimeter is 200. And so we've got 2x plus 2L. So remember that's going to be a 100 equals x plus L. And we want to solve for L, so L is 100 minus x. And then area will be length times width. And so we can use this. We can expand it out as well. That would be 100x minus x squared. We could also show it as negative x squared plus 100x. But really, you could keep it like this in your calculator, okay? Now, instead of a in your calculator, you're going to use y. So it says, use your graphing calculator to graph the area function. You'll likely have to adjust the windows, refer to your table for appropriate values. When changing the window, remember that x represents the width and y area, and then sketch a picture. So, calculator out, go to your y equals, clear off anything that you had, and then as I said, you can keep it as 100 minus x times x. Window setting, think about the graph. You went from, basically in the graph, it went on the one you did by hand, the scale was negative 10 to positive 100 for y, and it went up by tens. And for y min, it was a little bit below. So that was about negative 200 to a maximum of, let's say, 3,000. It went a bit above, but okay. And then that went up by 200s. Okay, so now let's graph that. So you can see that on the left, the graph goes below the x-axis, even though in real life it doesn't make sense. That's just because we are modeling this particular situation with a quadratic that goes on forever. Okay, so now we're going to graph this here. So notice how there's no scale. We're going to do a sketch. So I'm just going to do my best to do a symmetrical parabola. This is my width. This is my area. Okay. Sketch a picture, labeling the axes, and write your window settings. So it doesn't say that you have to show the scale. My window settings, what I did was I went from negative 10 to 100, up by tens. I went from negative 200 to 3,000, up by 200s. Okay. Then it says, use the calc function on your calculator to determine the maximum value for the area and then what it refers to. So, on your calculator, how do you find the maximum? You can kind of estimate by tracing. So if you press trace, you can cursor back and forth and see different coordinates. Now where you think it's the maximum is about there. Turns out your calculator got it spot on. But it doesn't always, just because of the pixel sizes. So what you want to do is know how to get the calculator to get it as exact as possible. So how do you do that? Set calc. So that's second key, trace key. You can see the word calc above. We want to find the maximum point. So cursor down, enter on that. And then notice what it asks you for the left boundary. So it's flashing on the graph. Enter. So press enter if that's to the left of where you think the maximum is, which it is. If, say, yours shows up differently, move it till it's to the left. Then now you're going to have to cursor to the right until it's to the right of where you think the maximum is. Enter on that, and then it'll say guess. Now it's not just a random guess. The calculator gets it, but again, pixel sizes make it maybe not, it's going to be within like 5 decimal places. It'll be correct. But in any case, enter on that. And in this case, it goes exactly to it. So 50, 2,500. So the maximum value is the y value, 2,500. That occurs when x is 50. And remember, x represents the width. Okay? So here, the maximum area is 2,500. And the corresponding width is 50. Write down the steps you use to determine the maximum area. Is the maximum value the same as the value you got? So it sure is the same. What were the steps? So we wanted to do second and then calc. So second key, and actually I'm going to put trace key because that's really what we did, which is the calc feature. And then you cursor down or entered 4, because that's for maximum. And then you set the left boundary, then set the right boundary. Okay, enter after that. Enter after that. Okay, so left boundary, enter, right boundary, enter, and then it says guess. So you press enter. Okay, and ours went right to 50, 2,500. It really kind of depends what your boundaries were. It might be 49.9999, 2,500, and really that rounds to 50. It is exactly 50. That's just because of the pixel sizes of the calculator. Another feature of your calculator, use the table function to determine the areas for various widths and the widths for various areas. So, calculator out. Then it says second table set. So if you look at window, it's really second window key, gives you the table set. So it's the setup for a table of values. Okay, we want to start at 0. And we want to go up by 5s. Not by 1s, we'll go by 5s. And then leave it as auto for independent and dependent. Then go second graph, which is table, and you will see all the values. Starting at 0, going up by 5, so you can see when you get to 50, you get 2,500. So use the table function to determine the area when the width is 25. That was 1875. 45, 1475. Okay. Use the table function to determine the width when the area is 2100. So look up 2100 there is 30. And you'll find it again at when x is 70. Okay, so this is width equals 30 or 70. 2275 is 35, so if you cursor to 2275, that's 35, which is or 65. Okay. Use the second calc function on your calculator to determine the area when the width is 28. So, this is a little bit different. So second calc, so I'm going to quit out of my table feature. I'm going to go look at my graph. Okay. So we want to determine the area when the width is 28. I'm actually going to, you can use the second calc. It's a little bit more time consuming. What you're doing, these are actually x values, right? So this is x equals 28, and we want to know what the area is. So if you go second trace, which is your calc, and go to value, so just enter a number 1. It shows you an x equals a flashing. Well, that flashing, you're saying 28. Enter on it. It'll go to the point on the graph where x is 28. So y is 2016. Okay, now that requires you to go second key, trace key. What's a little bit nicer is if you're in trace mode, so just anywhere on your graph, make sure you see the cursor. And if you just punch in, so the next one, 41.4, the calculator automatically assumes that that's an x value. So now if you enter on that, it goes to the point where x is 41.4. So that's 2,426.04. That is faster. So if you're looking for a y value for a given x, be in trace mode, just enter it in. Now, vice versa, we want to find the width that gives an area of 1900 from our graph. Unfortunately, there isn't a feature where you can just punch in a number, 1900, and it will give you the x value. Because these are the y values. But think about it. You do have a y equals. So now you're saying, okay, y equals 1900. So remember how we did systems of equations. We're really solving that system of equations. So when we graph it, there's actually going to be 2 points. And if we go second trace, which is calc, now another feature in that is intersect. So enter on intersect. It's flashing. It's asking you, is that the first curve? Yep. You only have 2 curves. Second curve? Yep. Guess? Yep. And it goes to the closest point of intersection. So that is 25. Doesn't say what to round to, so we'll go 25.5, 1 decimal place. Okay. Now, there's another one. Because remember, the length can become the width. So if you have 2 and you want to find both of them, really we could just subtract that from 100. But if you want your graph to do it, then you can go second, trace, intersect again, or just press 5. But we need to get closer to the other point. Otherwise, it'll keep giving you the same point of intersection. So closer over here, enter, enter, and then guess is 74.5. Okay, and if you added those together, you get 100. So then same for 2200, go back to y equals, change your 1900, clear that off to 2200, graph those. And then second, trace, intersect is number 5. Enter, enter, enter. It'll be width equals 32.7. And then it'll be 100 minus that, or practice using your calculator. Intersect, Cursor closer to the other one. And that's 67.3. Okay. That's it. So we've learned some features of our of a quadratic and how to use our calculator. We're done.